Hello, thank you to be here for my Chiastek and Cosimate presentation. My name is Mathieu Gilles. I'm a technical specialist at Chiastek. I'm at Chiastek since 3 years and I hold a master degrees in IT science and project management. In this presentation, we will start with a presentation of Cosimate Chiastek. Next, we will see a paper on subject how implementing multi-FMU in a co-simulation platform. And last points will be a video, a demo to how export a model with Simulink and import an FMU into Cosimate. Okay, so let's start with the Cosimate and Chiastek presentation. Chiastek is a worldwide enterprise. We provide a software named Cosimate, which is a co-simulation tools used in automotive, aeronautics, and other domains to help engineers to develop a complex system. So Chiastek is a ECMB privately held with 3 companies, Chiastek in Toulouse, France, where is the R&D, Chiastek in Chicago, and Chiastek in Düsseldorf. We work with some distributors as Azapa, Get Technology, Simtech, Dahantech, or BSIM, and we have some partners, some Altran, DPS, and Shure Altair. Cosimate it is more than 250 licenses active and more than 300 active users and a worldwide customer support. Clients are various in aeronautic as Boeing, Airbus, Altran, Safran, and in automotive with PSA, Toyota, GM, Denso, Continental, Hitachi, and others. And in other domains where the co-simulation can be and help to create complex system, we can cite Hitachi in other domain of automotive, EDF, or Parker. So we have written some paper, and currently I'm writing a paper on implementing multi-FMU in a co-simulation platform to validate these FMUs. So I invite you to contact us, and we'll give you all materials. So Cosimate is the operating platform to co-simulate a system. It manages simulation software resource, provide common service for model and program, schedule tasks for efficient use, support operating resource and services. So it is a platform for multi-physics and co-simulation. It is a co-simulation environment. So it's composed of an open bus architecture, a network with network solution. Cosimate can be used as a part of development platform, as a part of test platform, and as a part of verification platform, which support co-simulation between different abstraction levels. We don't have regression of the model, but we work with native simulator. So the process and data management capability of Cosimate is an help to engineer to configure a system with an achieving version in design of experiment, exploration, performance. Cosimate supports coupling standard as FMI1, FMI2, DIS, and HLA. So regarding 1D simulator, there is a list of coupled tools. We can cite Demola from Dassault, GT Power, Simulink, ModelSim, Easy5, Open Modelica, AmSim from Siemens, and Saber from Synopsys. Now a list of 3D simulators controlled by Cosimate. So we can cite Flux from Altair, Inventor from Autodesk, Adams from MEC, CarSim from Mechanical Simulation, and CarMaker from IPECH. And Cossimate support other generic tools, as you can see. Okay, so it's finished for the general Cossimate and Chiastek presentation. Now let's talk about my paper, how implementing multi-FMU with the Cossimate co-simulation platform. So everyone know FMI, I think. So FMI is a standard for co-simulation at system level. In our paper, we will present a strategy to instantiate models between internal and external stakeholders using different modeling tools. The Cossimate software is the co-simulation platform that allows the co-simulation with native and with the FMU's model, and this will help us to validating simulation workflow. So in our paper we will discuss the benefits of native co-simulation to prepare FMUs for co-simulation. We will define some prerequisites to export correctly and run properly an FMU using commercially available simulator. And we will guide the integration of the FMU inside the co-simulation platform. So, the Cossimate software is a platform for co-simulation that allow co-simulation of both native and FMU's model. So this will help us validating the simulation during the transformation of model to FMU. The native co-simulation is a known example. So in our paper we present the example. It is a model cylinder engine which is hosted by GT Suite. We have a controller with a Simulink model which controls this engine, and an MC model which is a simple converter inside our co-simulation. So native co-simulation will help us to validating the original results, and this result will be compared later to results of FMU's co-simulation to validate the system with FMU. So the three tools are Simulink, AmSim and GT Suite. In our paper we will guide and inform documentation existing to export properly a model with Simulink, a model with AmSim and a model with GT Suite. So once FMUs are exported, co-simulation can be rebuilt using FMUs. So at start we have three native model inside our co-simulation, and once an FMI model is exported from one of three tools, we can import this FMI model inside our co-simulation with Cossimate and with other native model to validate this FMU inside the co-simulation, comparing new results with original results. So the setup is very easy for FMU's co-simulation, and the configuration of an FMU for co-simulation is less than 10 clicks. So this is a FMU connector we will present. It is a tool used to control FMU once it is exported, and we will configure co-simulation parameters inside FMI connector. Next chapter is distributed co-simulation. We can use distributed co-simulation with FMUs as any tool controlled by Cossimate. The distributed co-simulation is a real gain of time, because the principle is we don't have an exclusive host which have all model of our co-simulation and needs to run all inside the same computer. Here, with the distributed co-simulation, we have three computers located at different place linked between us with a VPN, for example. And in this case, we can have a co-simulation system running through different country. For example, a video is available on Cosimate website with distributed co-simulation. And the second point advantage of distributed co-simulation is the confidentiality, because we don't have to send a model to another actor of the co-simulation, and results of our model is located at place of model. So we send just information we want to send, and we don't have an export of model. So logs are very important with FMU, because FMU don't have don't have interface to access to the FMU content. So it is the first role of a co-simulation environment for FMU. So logs is very important here. FMU in logs of the FMU connector, which is the tools used to control an FMU with Cosimate. Inside the log window, we will have FMU's logs, so information about FMU and run or configuration information, and co-simulation logs. It will help us to configure properly the co-simulation environment. Next chapter is the results. So the results are the base of our example, because we compare results to validate the case. So Cosimate has a tool named CosiScope, which can be used with the CSV option. So inside co-simulation, when you run a co-simulation, you have an option named CSV option, and once it's checked, each model of co-simulation will create a CSV file to store data transited by the model during the co-simulation. Once CSV option after co-simulation is created, we can use CosiScope tool to import CSV file to interpret values. So, to conclude, in our paper, we will discuss about the FMU validation using Cosimate, how we can use Cosimate to validate FMU, advantage of native co-simulation, advantage of distributed co-simulation, and finally FMU advantage. So if you want to get this paper, don't hesitate to contact us. Now I want to show you a video on a more simple example with a FMI model, which is a shopper and a controller with as original model Simulink and PSIM. Good watching. Hello, I'm Mathieu from Chiastek. In this video I will demo to you how to export a Simulink model as FMU and use it on co-simulation with PSIM using Cosimate. The example used is PSIM Simulink from Cosimate installation. Let's run the original co-simulation example using PSIM and Simulink. It is configured, so we just have to click on Run Interactive Co-simulation to run it, and follow the Cosimate instruction. We can now click on Run and check the results. Now let's change the simulating model to generate FMU. We have to replace ports, cosimate ports, by simple simulink in and outputs. Once ports are replaced, we have to create a project based on model. XD can be imported into cosimate. Verify port links, check cosimulation, and run it. CSV option of cosimate bus can be useful to analyze results of FMU model. When we build a cosimulated system, it's recommended to enable verbose mode using tools, option, and log. This option allows you to see more debug logs on cosimate and its models. FMUs exported from MATLAB require FMU session to run. Now we can run the cosimulation using PSIM and FMU model. And check results. Thank you for watching.